Just real quickly, GDS in California. I'm sure a lot of you have never heard of GDS, headquartered in Marietta, Georgia. Let me just put some context on that. I think a lot of you have heard of EES Consulting, who are headquartered in the Pacific Northwest and do a lot of energy consulting on the West Coast, including California. And more recently, around 2015, getting involved in CCA development work. Early last year, GDS Associates purchased EES Consulting to kind of leverage their client base on the West Coast and offer other GDS services out in this neck of the woods. There is a slide later on that shows all of the GDS services. I'll save that for Dick, but the point of this presentation is that GDS does a lot of energy efficiency and other DER potential work for utilities across the country, and most recently a huge effort for the California Municipal Utility Association members. So this is an area that is a very strong suit for GDS. Dick Spellman, who's the main presenter, he's either led or been involved in probably every one of those studies. And Melissa Young is part of a team that's going to pick up the efforts that Dick has started in developing this type of work and lead it forward at some point in time when Dick retires. So with that, I'm going to leave it there and turn it over to Dick Spellman to just jump right into the presentation.
All right, let's see. Howard, can you hear me? Oh, you're on mute, Howard, but I'll assume you can hear me.
We can hear you.
All right. Well, I just wanted to thank Howard for the introduction to GDS, and also just to reiterate that there is a place to, if you have questions as we go along, there is I think a panel somewhere there in Teams where you can write your question and submit it, and we'll answer the questions when we get to the end. My co-presenter is Melissa Young. She's a mechanical engineer with GDS, and we're pleased to be here today. I wanted to mention a couple of things before I talk about the agenda. So Howard or June, if you're controlling the slides, let's go back to slide 2 just for a second. I think it's slide 2 you want to go. Yeah, great. I wanted to mention, as Howard said, we work with several community choice aggregators. Several states in the United States do have CCAs, and my understanding is there are over 20 of those in California. Earlier this year, I had an opportunity to do some work for the Redding utility up in Northern California, and had a chance to collect all of the laws and regulations in California that affect regulation of municipal utilities. And so I have a good understanding of what the requirements are relating to energy efficiency potential studies and implementation of energy efficiency programs for municipal utilities and CCAs. My understanding is that as of today, there's no existing law or regulation in California that would require CCAs to do energy efficiency potential studies or to implement energy efficiency programs. The other interesting thing about California is that CCAs can access the CPUC energy efficiency program funding. And my understanding from Howard is that several CCAs are now taking advantage of that. And as a result, as the CCAs begin to design and implement programs, there's a greater need for an energy efficiency potential study. And what Melissa and I will be talking about today is what's the purpose of those studies and how can you use the results. We'll also cover a little bit on demand response potential studies as well. So for our agenda today, I will cover the objectives of this meeting. I'll talk about what the purpose of a potential study and the methodology we use to do them at a high level. And I also want to talk about the study that Howard mentioned that we recently completed for the California Municipal Utility Association. I believe it was for 38 municipal utilities. Jeffery Huber is on the line too, and if I got that number wrong, he can correct it. But Jeffery led that study we completed recently for the California Municipal Utility Association. And then we'll take up your questions and provide answers. Okay, let's go to the next slide, which is slide 3. I'll go back one slide. There we go. I just wanted to show you pictures of myself and Melissa. I think maybe you can see me, but Melissa may be hidden among all the list of participants here in the meeting. I've been with GDS for about 28 years, and before that I worked for a utility up in Maine. I've been in the energy or utility business for about 44 years, and haven't retired yet, still going strong. Melissa is a graduate of Georgia Tech as a mechanical engineer, and she has done a lot of work with demand response potential studies. So Melissa will be talking about that type of study. And Jeffery Huber of our firm is also on the line. He also has worked on a lot of these types of studies and is available to help Melissa and I answer any questions you may have. So going on to the next slide on the objectives, and we want to talk about we want to introduce the concept of energy efficiency in demand response potential studies. We wanted to talk about the data we use, where we get it, the methodology we use to estimate the different types of energy efficiency and demand response potential. We want to talk about some of the data sources we use and present the findings of the study we did for the California municipal utilities. Going on to the next slide, on slide 5, and this is an old favorite of mine. I know it takes a second for the slides to change and show up in Teams. So if we could go to slide, there it goes. You'll see on the right a reprint of the cover of a publication that was put out by the National Action Plan for Energy Efficiency. And for those of you that are contemplating doing a potential study or you want to know more about them, that's a good source of information. It's available online, it's free, it's a public document. It's a guide for conducting energy efficiency potential studies, and the methodology in there can be used for demand response potential studies as well. I realize it came out in November 2007, but the concepts and methodology are still true today. And you can see there's a quote here from that document that says that, simply put, an energy efficiency potential study is a quantitative analysis of the amount of energy savings that either exists, is cost effective, or could be realized through the implementation of energy efficiency programs and policies. Like I said, that document is available online and highly recommended. And a potential study, in my view, is simply, it's a good roadmap. If you have a CCA and you're thinking about tapping into some of the California Public Utilities Commission energy efficiency funding that's available, a potential study helps to identify what are the measures that have the most savings and which measures, energy efficiency or demand response, have the most potential, and which ones are the most cost effective. So that's really the purpose of a study, is to give you a roadmap so you know where to begin. If you're starting from ground zero and your CCA is thinking about implementing programs like this, it points you in the right direction. Let's go to slide 7. Now on my screen, I guess I don't have this full screen, so I'm looking at a paper copy so I can see the small print. But this diagram shows you it's a process flow chart of how firms like GDS and other firms do these studies. And basically, we start with the utility load forecast, if there is one, and if there isn't, we can create one. But we're looking at what's the outlook for sales of electricity for the next 10 or 20 years by class of service: residential, commercial, industrial, other, including street and area lighting, things like that. And then we like to get as much detail as possible that breaks down the forecast by sector, by housing or business type, and then by electric end use. And then in the next step, we make sure we have that disaggregation. If it isn't available, we can use our models and data to break down a forecast into that type of detail. So we have a good picture of how is electricity used by residential, commercial, and industrial customers, and when is it used, and how much, that type of thing. And then from that, we can figure out which measures are appropriate and where can they be applied to help save electricity. So in the third step, and I'll talk about these steps in more detail, we collect data on energy efficiency or demand response measures. And then in the fourth step, we start to turn the crank to estimate, okay, I'll use water heating as an example. If we had 100,000 electric water heaters and they were all inefficient, and we changed them all out tomorrow so they were efficient electric water heaters, what would the savings be if you did that for all 100,000 water heaters in one fell swoop? And then in the next step, we determine whether these things are the measures that you would do, like a high efficiency water heater. We test it for cost effectiveness. And California has been a leader for a long time in looking at the cost effectiveness of energy efficiency or demand response. The California Public Utilities Commission has had a manual for a long time, ever since I can remember, back in the 80s, called the California Standard Practice Manual, that lays out different tests. And it's my understanding that the commission just came out with a new test. I can't remember the name. It's something like the total system test, just in the last 2 weeks, according to a press report I saw. So anyway, you do a test to see if the measures you're planning to do are cost effective. So, and then the last step, we take into account what's the likelihood that utility customers will purchase and install these measures without utility programs and then with utility programs. And that's called achievable potential. So just to recap, the first step, we're looking at the technical potential. What could you do if we don't take into consideration cost effectiveness and we don't take into consideration that not everybody's going to do this? And then the next step, we test for cost effectiveness. And in that last pyramid, then we roll in, what we think the likelihood is that customers will adopt these technologies. So that's a lot of material in 3 or 4 minutes, but that's the overview of the process. And now Melissa and I will talk about some of the steps. All right, we're down to, I numbered these things by step so that you can see that there are, I guess I had in my chart maybe 6 steps. So in my slides, I come close to that. So in step 1, what I recommend doing before we do anything, if you're going to do a potential study yourself, or you're going to hire a consultant, and there needs to be a meeting of the minds on what is it we're trying to do, what methodology will we use, what's our approach going to be, which cost effectiveness tests are we going to use, what are the available data sources, and is the CCA load forecast, is it available, or do we have to develop one? And then there should be a discussion of, how are you going to estimate the likelihood that customers will want to participate. And then you have to take into account things like codes and standards. What's the baseline for these technologies in terms of their level of energy efficiency? And, typically, studies like this say, okay, the baseline technology will assume it has to be up to the federal code. And then you see what you can save if you put in energy efficiency measures that are above the code. And then there are factors like, what are the savings going to be like if you're doing, if you're in an existing home and retrofitting it versus building a new home. So there are lots of things that need to be discussed up front and finalized in terms of the approach and methodology. These are just a few, but I wanted to provide some examples. And a consultant like GDS, we would sit down with our client and lay out a work plan, a detailed work plan, and explain some of these the key assumptions we're going to be using in our methodology, and then talk to the client where decisions have to be made about, well, gee, where can we get avoided costs of electricity that are going to be needed for cost effectiveness testing, or what is the load forecast available. So the step one is really to nail down the approach, methodology, data sources, etc. Okay, let's go to slide 9. Okay, now we're up to step 2. We've had our discussion, we've laid out the work plan and what our approach is going to be, and now we have to collect a lot of information. And I would say, a potential study has a lot of information in it, and the degree of granularity of a potential study, to some degree, will depend on how much data is available. Whether the utility or the CCA has available things like appliance saturation studies that say what % of households have various appliances and energy efficiency measures already in place. So this slide has a list of some of the things that will be needed, like the utility's load forecast, forecasts of electric and natural gas avoided costs. And because we're going to be looking out 5, 10, 15, 20 years, we're going to need things like forecasts of the general rate of inflation. We're going to have to decide what discount rate are we going to use to discount future cash flows back to the present. Do we take into account planning reserve margins? And that whole concept is that if you save a kilowatt at the meter, you save a little bit more at the generation level due to line losses, electric line losses, as well as the fact that utilities have to have reserves when they size the amount of generation capacity. They have to oversize it to allow for planned outages and unexpected outages. So there are things like the planning reserve margin. Many jurisdictions use about 15% for that. And line losses vary. On average, they might be, I don't know, it depends on the utility. It depends whether you're a distribution utility or a vertically integrated utility, but can range from 3 to 10% on average, and then at peak load times, the losses tend to be a little bit higher. And then we have to collect a lot of data about energy efficiency and demand response measures. So, like for the water heater that I mentioned, you would collect, you'd have to establish what's the baseline water heater and what's going to replace it. And the baseline would be, if you went out and bought a water heater today, what would the standard efficiency water heater use for electricity for a year? And then you would look at a higher efficiency model. So the baseline water heater would be the one that's required by federal appliance efficiency standards or federal code. And so you would collect data on what are the kilowatt hour and kW savings on an annual basis, and you would collect data on what's the cost difference between the two technologies, and also what's the useful life of a water heater. And then you would repeat that process for all the other measures. And typically in an energy efficiency potential study, we're looking at dozens and dozens or hundreds of measures. And then you'd collect data on equipment saturation. And the same thing would be true for demand response measures, whether it's critical peak pricing or water heater load control or other demand response measures. So we'll go to the next slide. Let's see, it's the one on measured. Okay, good. And I talked about this. I won't spend a lot of time on this slide, but we consider a lot of measures. And in fact, in the process of doing these studies, oftentimes we'll talk with the client and with stakeholders who are involved in these studies. Could be customer groups, could be environmental groups, could be regulators, depending on the client. And they may suggest additional measures. And we use all that input to create a final measure list. And we give that to the client to review and comment on. And oftentimes we rely, many jurisdictions, including California, have a technical reference manual. And so, for example, when we did our study for the potential study for the California Municipal Association, the CMUA, as I call it, had a technical reference manual, and we use that as our default data source on measure costs and savings and useful lives. Continuing on with step 2 on the next slide. When we're developing, a list of the measures that we're going to consider, we usually start with whatever TRM exists and is available for the jurisdiction where we're doing the study. And then we'll supplement using other data sources from the United States Department of Energy, and as I mentioned, from the client, from key stakeholders, and maybe emerging technologies that are being considered in federal government laboratories. All right, let's go to the next slide. So other key data sources, well, because you're in California, a lot of work has been done and is being done by the California investor-owned utilities and government agencies, program evaluation studies that show what the savings have been from programs implemented recently. That's a useful data source. Many of the larger municipal utilities and then the California investor-owned utilities have done energy efficiency baseline studies that give you a good picture of what's the current situation in California for the baseline level of efficiency of residential, commercial, and industrial electricity using equipment. And then there were also federal government surveys that break down the similar data, but on a regional basis. One is they're all done, most of them are done by the Energy Information Administration. There's a residential energy consumption survey, a commercial building energy consumption survey, a manufacturing energy consumption survey, and all of those can be used to supplement data that a CCA may have. And then there's also data from local government on income qualified households. So if you're concerned about surveying and providing energy efficiency to underserved communities, a lot of the state and local governments, agencies in California can help provide that type of information. And then, of course, you have the Bureau of the Census that can provide data on population, households, and numbers and types of businesses. And there's the Bureau of the Census also does an American Housing Survey, and they have lots of data on cities across the United States. Okay, the next step, this is kind of the nuts and bolts of the whole process. So I'm up to step 3, and this just shows you a simplified version of the equations we use to calculate potential. And I'll just give an example. I'll go through the diagram, the first line there that talks about the equation we use for the residential sector. So in this equation, basically, if I use water heating as an example, it'll figure out how many, by putting in data, we'll know the number of households that are in a CCA service area. And we can use either a CCA data or census data or other data to get what percent of households have an electric water heater. And we can multiply the two together, the number of households times the saturation. And then we use an applicability factor to figure out whether the technology is suitable and applicable to this particular market, and then a savings factor. So if we had 200,000 households, for example, and 50% of them had electric water heaters, and none of them were energy efficient, so that'd be 100,000 old water heaters. And if we could replace all of them with a high efficiency water heater, and the high efficiency saved 20%, we would just multiply all those numbers together to get how many kilowatt hours we could save a year. And that would be the technical potential. If you could if you could snap your fingers and do it overnight, eventually what we do is figure out, well, you probably can't do all of this overnight because it's going to take people time to agree to, replace their water heater. And we take the approach, for the most part, that will replace things when old technology wears out. So the energy efficiency savings, they'll happen over time as the technologies burn out. But there are some markets where retrofitting can be done at any time, like with household insulation or windows, high efficiency windows. Now, I know that was a quick explanation of the equation, but basically we collect all of this data and put it in a large model, and we have this type of calculation for all of the technologies in the residential sector. And with modern technology, the calculation is done in a few seconds, and it tells us what the technical potential is. Okay, the next slide talks about the types of energy efficiency potential, and I'll spend just a second on this. We talked about the technical. That would be, what could you get for savings if you could do everything, get 100% adoption? And then the next level is the economic. So that would be, it's a subset of the technical, and it would be those measures that pass a certain cost effectiveness test. And in this case, I said the total resource cost test. And in that type of test, basically, you're just examining what are the costs to adopt the new technology, purchase the new water heater, and it would be the incremental cost of a new high efficiency water heater compared to a standard efficiency water heater. And then the benefits would be, okay, how much do we save in electric generation, transmission, and distribution? How much do we save in dollars, because we're not going to be using that electricity? And so you multiply the kilowatt hour and kW savings times their respective avoided costs for energy and capacity. That's a very quick explanation, but it's basically you compare the costs of doing the energy efficiency to the benefits by avoiding generation, transmission, and distribution. And if the benefit cost ratio is above 1, then it's cost effective. The third level, we roll in, what we think is the willingness of customers to participate in the program. And we'll talk about these more as we go along. Let's go to the next slide. And at least on mine, this is pretty small print, but basically, we usually do 2 or 3 scenarios, and you can do more. The first case, we say, what's the most you could get? And this would be the maximum achievable potential. And I guess on the slide, it has maximum second, but okay, so just keeping with the slide terminology, the reference case, typically we would use an incentive level that would be paid to participants for what's the typical types of incentive levels that are provided by utilities in the region. Do they pay like 50% of the incremental cost of an energy efficiency measure? The second one is, what's the maximum achievable potential? And for this scenario, we typically assume that it's we're going to pay 100% of the incremental cost to get the maximum number of people to participate. And then a third one might be, we talk to the stakeholders, say, what would you like to run as a scenario? Because in many jurisdictions, the involvement of stakeholders, there could be customer groups, environmental groups, regulators. Having their buy-in is very helpful to get programs to move forward and to get approvals. Now I want to talk about, I guess I'm on slide 16. Okay. Forecasting market penetration. There is uncertainty in this. When we do these studies, we need to make forecasts of what do we think the willingness to participate will be, that customers will participate in these programs over the next 5, 10, or 15 years? And there are various ways of doing this. And GDS tends to consider lots of information. We'll look at what's been done by maybe by the CCA. If they've been running programs, we'll look what they've been able to achieve for participation. And we'll also look at participation levels and rates achieved by other utilities in the similar region as the CCA. We also have research techniques that we can use to help support the estimates of participation over the long term. And I'm going to talk about one of those. So let's go to the next page. It's called Delphi panel research. And in this approach, what we do is we get a panel of experts. They could be home builders, distributors of equipment, and other key actors, electrical distributors, and get them to respond to a survey that says, in this particular market, if we're offering this particular product, like a high efficiency water heater, and the utility or government agency, depending on who's running the programs, offered an incentive of 50% of the incremental cost, what percent of the eligible market do you think would participate over the next 10 years? Those types of survey questions. And we would maybe have a couple of different panels, maybe one for the residential non-low income sector, for the low income sector, and then maybe one for commercial and industrial. And the results of that type of research, and we might have anywhere from 10 to 20 experts on each panel, the results of that type of research can help inform what we assume in our studies for over the long term, 10 years or so, what can we expect to get for the percent of the eligible market participating. And we've had some good success with that approach. We also can look at willingness to participate research with utility customers, where we ask them if they'd be willing to participate if they knew the payback was so many years, or that the incentive was a certain level. So that's another type of research. So there are market research techniques that can be used to help fine-tune the participation. But certainly we do look at what utilities, for example, in a state like California, have been able to achieve. California utilities have been offering energy efficiency programs for a very long time, going back at least to the 80s and probably before. So there's a lot of experience in California. And the good news is a lot of the research that has been done in program evaluations is publicly available and can be downloaded off of websites like CalMac, for example. Okay, next slide, slide 18. And these are provides some lists of the types of experts that we recruit for Delphi panel research. And I mentioned home builders, but there are different contractors or businesses that we would like to have on our panel. They could be HVAC contractors, distributors, manufacturers, representatives from national labs who work on energy efficiency. And then I have a list there for non-residential as well. And the reason I mentioned it, one of the advantages of Delphi, well, there are two advantages of Delphi panel research. One, you've got experts, people who do this every day and work with these technologies. And two, it's not expensive. I mean, compared to other types of research, this can be accomplished relatively quickly at a very low cost. And that's, another reason why we like to use this with, municipal utilities and CCAs. Okay, the next step, I'll touch upon this briefly. When we're doing these studies, we do quite a bit of segmentation, and we try to take advantage of the data we have available to us. So the more we can break things down into class of service, residential, commercial, industrial, type of home, single family versus multifamily, type of business, and then segment further by electrical end use. Um, I think it's more valuable because then our potential study can really hone in on, where are the opportunities, which customers and which technologies, um, and we can come up. The potential study can provide very good guidance where to focus the most attention. And with that, I think I'm up to Melissa's slides. So I'll take a breath, and Melissa, if you'll take over for a couple of slides.
Sounds good. All right, so I'm going to be walking through some of the basics of the GDS demand response potential study. We typically consider over 20 different DR options when we're doing these studies. And we'll revise the list that we usually start with based on feedback from utilities. So utilities might want to add programs that they already have if we don't have them on the list already, or if they're interested in learning more about a different type of technology, we could add that. Or we may take out programs that they know that they don't have any interest in. And then we'll conduct a cost-benefit analysis for each demand response program. Next slide, please. So there are three main types of demand response measures that we look at. Direct load control is when the utility shuts off the participants and use when they've elected to participate in it during peak hours of certain peak days. So this could be like a physical switch that they actually install on the equipment, or it could be a smart thermostat for air conditioning or heating. And then customers are typically given an incentive or a bill credit for participating. The next type is pricing programs, which are when the on-peak rate is higher than a normal rate and the off-peak rate is lower than the normal rate. So the customer is encouraged to consume their power during off-peak hours so they can save money. And third, we look at aggregator programs, which is when the participants bid a certain load on peak days and the utility will call on the participants to shed their load. And it's typically for non-residential customers. And these participants are given an incentive based on how much load they typically shed. Next slide, please. So one emerging DR technology that we're seeing more of is battery storage. In DR, the utility can use the participant's battery during on-peak hours of high usage days to offset their demand. We've got a list of several different examples of batteries here that could be used, including Tesla's Powerwall, which is around $8,000 excluding installation. And there's typically two different approaches we would look at when considering this as a DR option. The first being that the utility would own and operate the battery and the customer basically just gets to use it if there's a power outage. And the second being that it's a cost sharing agreement. So the homeowner owns the battery and the utility give them an incentive for installing it, but then the utility can dispatch the battery like essentially like a direct load control switch. So that is all I have for demand response. Back to you, Dick.
There I am. Okay. Melissa, thank you. I just wanted to add two things. It's a very exciting time to be in this industry. I read within the last week, that the Biden administration has a new initiative, and I'm sure people have heard of this. They plan to reduce or try to reduce the cost of battery storage by 90%. So I think it's a pretty good goal, but it's going to be interesting to see if it actually happens. But so things are changing very fast. So maybe if the $8,000 for a Tesla Powerwall, maybe it'll be $1,000 in 10 years. Who knows? I even have a Tesla battery in my small RV I bought last year. So things are changing very quickly. The other thing I wanted to mention was that there are utilities with these types of programs that Melissa was just talking about, where the utility uses the electricity from the battery when it is in need of that type of power. And a couple of examples, one is Green Mountain Power in Vermont, and the other is the Glasgow Utilities. I believe that's in Kentucky. So there is information out there from utilities that are actually doing these things. Okay, let me go to slide 23 about emerging energy efficiency technologies. Another thing we consider in energy efficiency potential studies, new technologies are going to come along. So we try to scan the environment and see what are the types of technologies that are in development and will likely be in the market soon. And if it makes sense, we introduce those into the potential study at a time in the future when we think the technology will go commercial. And of course, there are other emerging technologies that have been in the market for a while, but just haven't gained acceptance. And as they gain more acceptance and their cost comes down, then they will. It's interesting when I remember back in the I can't remember. I guess it was in the 80s when the CFL bulbs were the rage, and then we've gone to LED, and the cost. I remember buying CFL bulbs for $30 a bulb. Not buying myself, but seeing that the cost was $30 a bulb, and that cost came way down. And now we have LEDs, and that cost has come down, and probably will go down further. But we do consider emerging technologies as well. The next page, slide 24, there are also, AMI infrastructure is providing some new opportunities. Obviously it allows customers and consultants to better understand usage trends and when electricity is being used and when it might make sense to, move or defer use to other periods in the day. And Melissa talked about this a little bit, but she's been doing a lot of work on, rate options, critical peak pricing, and other types of pricing mechanisms instead of what would you call it, customer behavior programs. So they are behavior programs, but there's a rate to give extra incentive and oomph for customers to change their patterns. Next slide. I'll just touch on this one briefly. We talked about different types of scenarios that can be done, and the reference case that we typically run is using incentive levels that are common, have been used either recently or by surrounding utilities, have been used by the utility that we're working for or by utilities in the region. And if everybody's offering an incentive of 40%, of the incremental cost of a high efficiency water heater, then we would propose that would be the reference case. And then we would look at alternative scenarios, maybe with the utility paying 100%, and then maybe there'd be a scenario proposed by stakeholders. So we do look at several different scenarios. And then we're up to step 4, where we actually have to write up and we have to present the results and write a report. And what I would say is the reports that we do, we try to focus on what our clients need. And usually they like, to have an executive summary that presents the results succinctly right at the beginning, so an executive can read it in a short period of time. And the most important findings and recommendations are right up front. And then the rest of the report would go through methodology, data sources, and then results by sector, residential, commercial, industrial. And if we're doing demand response as well, we might have a section on energy efficiency and a section on demand response, and also explain how, if you do energy efficiency, how that impacts demand response and vice versa. We also, as this slide talks about, in addition to the executive summary, we provide quite a bit of detail by sector. So when decision makers and utility planners or CCA planners need to think about, okay, what are we going to do? There's enough detail for them to understand where are the best opportunities, which ones are more cost effective, which technologies are the best, and we give them projections year by year, by sector, by end use, by building type, that type of information, and cost effective screening results. So these reports um, the report sections along with the appendices provide a lot of good information that really helps with the planning of programs. Okay, going on to the next step 5, I'm on slide 27. Typically, we like to also include in our reports a comparison to results of other studies, other recent potential studies. So, you know, if our findings are that you can save about 1% of annual utility sales, for example, and you could do that every year for the next 10 years, how does that compare to other CCAs in California or other CCAs in the western part of the United States, or to other countries? But mainly we focus on, you know, other utilities and government agencies that have done studies like this, and we provide a comparison so you have a feel for are the results that we're getting for your service territory the same or different than other recent studies. Okay, going to the next slide. Many places, many jurisdictions really get into a lot of detail, but not everybody does this. And I'd say the larger utilities get into a lot of hourly modeling of loads. And when we work for them, they really want to know, for forecasting out for 10 or 20 years, you know, what are the hourly impacts on their load shape by sector. And so we have experience, you know, doing the hourly modeling of energy savings or energy demand savings impacts, and then putting that data in a file that can be uploaded to something like Strategist or Aurora, which are the big integrated resource planning models. And we can transfer that data fairly quickly into those IRP planning models. But it's very voluminous data, but you know, we know how to do that. And then the next step, I'm up to slide 29. Appendices. At GDS, we've always taken pride in making sure that we provide good documentation of our data, our input assumptions for our potential studies, and then what the data sources are. So for every measure, we typically provide the source for the measures of its cost, kilowatt hour and kW savings, useful life, and saturation. And we put those in appendices because it's voluminous data, but a lot of our clients, you know, they want to know, okay, where did you get this? And how do we know your estimates of potential are realistic and are, you know, could happen? And we feel that it's important to provide that level of documentation in order to have, in order for our studies to have credibility. Okay, the next thing, and Jeffrey, you may want to chime in after I say something about this slide. This is the results of the 2021 energy efficiency potential study that we recently completed for the California Municipal Utility Association for over 30 municipal utilities in California. This goes out 10 years, and it shows the incremental market potential, and then it shows a breakdown. It shows the total market potential, and then a breakdown by residential and non-residential. And it also shows what the total sales are, total utility sales. And if you look at this chart, I'm focusing on the last column, which are the, you know, what are the annual percent savings of annual kilowatt hour sales. And it starts out being about 0.8%, then it drops to 0.7%, well, 0.77% in 2024. But the point is, it starts out close to 0.9%, and then by the end of the period, it's down to 0.45. But that's the type of detail we can provide, and then in our reports, it would explain, you know, why that is coming down over time. And you know, as you know, there are a lot of changes that happen. Avoided costs change as you go forward. Energy efficiency baselines can change as codes and standards go in. But I provided this just to show you the recent results for that we got for this study for CMUA. Jeffrey, do you want to add anything to that on that slide?
I think the only thing I'd add is just in talking about technical, economic, achievable potential. The market potential that's shown here is a little bit nuanced in the sense that it's really the potential based on the variety of different offerings, the current offerings that each municipal utility offers. So some utilities offer a much more diverse mix than others, and so you can see different elements of market potential based on that. So it's not all cost-effective measures necessarily. It really is a look of snapshot of based on what they're currently doing, where can they go with that offering. There's the opportunity to always add more. They could take a look and see if there's anything that they wanted to kind of add into their future forecast, but it's not necessarily an achievable of all cost-effective measures either. That's the only nuance I would add. And
it's my understanding that the municipal utilities, they need to file their plan with the CPUC. The CPUC, this isn't a plan, I guess they file this study, I guess, and then they file a plan. Is that right, Jeffrey?
Right, they file this study and they file their 10-year forecasts.
Okay. But I don't think they have a requirement. The CPUC does not say you have to save this much or else. It's more of a informational filing. Is that right?
This is Howard. I'm happy to jump in. The munis file their plans, their EE plans, with the California Energy Commission, the CEC.
Oh, right, you're right.
And whether they have to hit their hard targets or not, I'm not sure. I don't think that they have to. The CCAs would have to file a program plan with the Public Utility Commission to acquire the funding for their EE programs. And I have a question for you, Dick, around that process and where a potential study fits in, but I'll let you finish up. Seeing that there aren't any other questions, I at least have one for you, but I'll wait till you finish.
Well, let me finish the next slide, and then I'll wait breathlessly for your question. I just want to cover project deliverables, and I've talked about this some, but when we, as we do this project at the end, we want to make sure that we provide a very credible report, well organized, well written, with good documentation that presents an executive summary. Let me see if I can increase my screen. My font on that slide is pretty small. Anyway, an executive summary with methodology, data sources, and the results by sector that are detailed, and then appendices that provide all of the information I've talked about. And it's really important that this report be well done because it's typically scrutinized by the client and stakeholders, and if where it's applicable, by regulators. So there's a lot of work that goes into not just the study, but just doing a good job documenting how it was done. So stakeholders and other interested parties can really understand how we got to the numbers we do. And I guess I do have one more slide. I would just say that I have a slide, I guess it's not numbered, about GDS. We, about 50 or so of us at GDS work on energy efficiency and demand response. And we work on energy efficiency planning, evaluation, implementation, market research. We have a passion for this type of work, and our main goal is to focus on the needs of our clients and make sure that our analysis fits their needs. So with that, Howard, I'll take your question. Oh, Howard, you're on mute.
Thank you, Dick and Melissa, so much. You've caught us up on schedule despite our challenges at the beginning, and having not seeing any questions. Which, by the way, if you had a question, attendees, you would type it in the chat box. I think I said a Q&A panel. But anyway, let me just describe where I think a lot of the CCAs are, Dick, and kind of get your opinion on where a potential study fits in. So many of the CCAs have been operating for years, and some of them are accessing the PUC money for EE programs. Some of them are not. For those who are accessing the programs now, I would and if they haven't done a detailed potential study as you've described, I'm envisioning that a potential study might provide some information on how to make existing programs better. For CCAs that are operating but have not accessed this money, and in theory, if they're operating, they have access to net revenues that could fund a study like this to make an application to the Public Utility Commission, very detailed, very defendable, backed up with tons of data. So I think that's a clear path. There are also CCAs there are also cities and counties that are anticipating becoming CCAs and are not in operation, do not have operating revenues, potentially to fund studies like this to then submit to the commission. We're working with one CCA client right now who is not in operation yet, and we're trying to use the data and information you've talked about here to present a credible submittal to the Public Utility Commission. So let me just ask for your opinion on those CCAs that are not in operation yet, don't have access to net revenues. What would be your recommendation on if a potential study light or some other, less detailed or comprehensive version couldn't be enacted to support getting programs running as early as possible to an initial CCA initial operation date? I know I talked for a long time. Did that make sense?
Yes. Well, I have two thoughts, and this is little the thinking outside of the box. One is that up in the Pacific Northwest, and Howard, you may be aware of this, they have come up with a conservation, what do they call it? CPA, Conservation of Potential Assessment, that's streamlined. And what they've done is they've created, and I can't remember, Melissa, you may know, you've worked with that recently. Is it the Northwest Power Coordinating Council, or it's one of those councils up there that has created a model with a database, which makes it much less expensive to do a conservation potential assessment. And so I'm just thinking out loud, if you took that approach, and if this, Jeffrey, is the SIMUA technical reference manual publicly available, do you know?
It is out there, but even the municipal utilities are kind of shifting a little bit towards the ETRM that California has.
Okay. But so I was going to say that the choice number one would be to do something like they do in the Pacific Northwest, where they've streamlined the process to make it easier for public power organizations to do these types of studies. And the firm we just bought, EES, has been doing that, using that model, and they have taught us how to use it. I would transfer that to California, that approach, and then, my understanding is that the California ETRM, perhaps, I have not used that yet, but I imagine it's fairly comprehensive and large, but maybe there's a way to use an approach like that to bring the cost down. So that would be one way. The other thing you could do, and again, if they don't have a revenue stream, I have a sense that there are foundations that will support studies like this, whether it's the Bill Gates Foundation or, there's an energy foundation. I can't remember what it's called, but it's either in Utah or Colorado that funds efforts like this. So there are ways to do this at low cost. And the third thing would just be to have a scope of work that's it would be to do as you said, a potential study light. So instead of doing a comprehensive one that PG&E might want, maybe you're doing a light version that gets you started, that's at a much lower cost because it's not as comprehensive. So there are several ways to do that and to get enough data so you can get the ball rolling, enough information, enough of a roadmap. Jeffrey, do you want to add to that at all? You've done a lot of these studies.
No, I think those were fine ideas.
Knowing Jeffrey, he could come up with probably 3 more, but those are the types of things that I would suggest.
Okay, and let me just add that EES/GDS have had conversations about this sort of dilemma with the Public Utility Commission. We can report that the Public Utility Commission, the Energy Division, is very excited about the idea of CCAs getting into customer programs, and this dilemma of not having a bank account or a revenue stream in advance of going into operations is something they're looking at, and hopefully maybe down the road we can present a regulatory solution on how CCAs or groups of cities within a CCA can get started as early as possible. So we are right on time given our late start. Thank you, Jeff and Melissa and Jeffrey Huber for weighing in on this, and really thank you to June Holt and Leora from Cal CCA for avoiding a technical disaster for us on people signing in. So we really appreciate, I can't tell you how much I appreciate that. So we're going to call it a day now, and thank you everyone. By the way, the recording of the presentation is available, will be available in the Cal CCA archives. And if you reach out to me, I can get the deck to you. I think Cal CCA will have the deck as well. So everything will be available. Thank you everybody for hanging in and sticking out and joining us. Thanks so much.